It's really important to understand the procedure and how to solve one of these questions. Always watch. The first things first, always isolate the variable. So you always isolate it, always try to make it into something like cosine equals 2, cosine x equals 2, or sine x equals 2, or secant x equals 2, or whatever, right? The second thing then, okay, once you've isolated, apply the cast rule and determine what quadrant this thing is in. That's the second thing to do. Then the third thing, absolute value it and solve, and you're going to find your theta reference. Apply that theta reference to wherever this thing happens to be. Done. Then determine the final angle. Okay? Determine the final angle. Right? Based on not only the cast rule, not only finding the theta reference, but where it is, either here, or wherever it happens to be on the unit circle. Well, let's do that for this one here. Check this out. Look at this. Oh my God, I gave you secant x. Oh my goodness. Right away, I'm throwing you into the deep end of the pool, right? Not true. Think about this. This is an algebraic expression, okay? There's secant of x, right? Minus 5 equals the secant of x minus 3. Let's start combining like terms. There's a secant x here. There's a secant x there. Bring that secant x over to the other side, which means you have to subtract secant x from both sides. Oh my goodness, that's really easy to do. That's gone, leaving you, oh, look at that, 2 minus 1. Ooh, so tough. This is going to be your secant x then, minus 5 equals to minus 3. Keep on solving this until it's isolated. All right, so that means add 5 to both sides. Look at this. You have secant x equaling to 2. Now, you know and I know that secant is the flip of, think about it, cosine. That's right. So, in fact, this is the flip of cosine x. So, guess what? I'm going to flip it back, which means this guy, I got to flip. Because if I flip this guy back, I have to flip this guy to that. Okay, perfect. Now that we've isolated, we're good. Let's apply the cast rule. Well, think about this. If we're applying the cast rule to this, add sugar to coffee, where is cosine positive? Well, here and here. Oh, how beautiful. Okay, so now we put the absolute value on this. But I know you're probably saying, oh, well, why should we absolute value this? It's already positive. To get into that habit of absolute valuing. Okay, now that's absolute valued positive 1/2. Then go into your unit circle now, right? Remember, where is positive 1/2? Well, you've got this nice narrow rectangle right here. There's the ones that are all based on the 30-degree increments, right? They're all based on the 30-degree increments, right? 30, 60, 90, and so on and so forth. Think about it. Where is this positive 1/2? It's positive 1/2 here. At where? Well, go back and look. You're in pi, you're in radians. So give me radians back. Oh, okay. So that's pi over 3. There's your value. X equals to pi over 3. But remember that that is a reference angle. So we've done the cast. We've got the reference angle now. Now we have to determine this based on what we had. Okay. So based on the cast rule, you know and I know where the cosine has to be. The cosine has to be at pi over 3 here, okay, or at pi over 3. So this is going to be from here to here is pi over 3, and from here all the way down to here is also got to be at pi over 3. Okay, so what are my actual values? Well, this one's easy because it's in the quadrant 1. So my actual answer is going to be pi over 3. But my question is what is this guy way the heck down here? Well, it's this guy, remember? Right? Think about it. Pi over 6, 2 pi over 6, pi over 3, 3 pi over 6, 4 pi over 6, right? There's our 6 pi over 6 over here. Whoops, I made a mistake. pi over 6, 2 pi over 6, 3 pi over 6, there we go. 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, and 10 pi over 6, right? There is a pi over 6, which we know is 5 pi over 3. So my other answer here then is 5 pi over 3. There we go. That's how you solve these things. Now, if you want this, now look, it's between 0 and 2 pi, which is exactly what I gave you, between this and all the way around one rotation. That's up to here, of course, that's within the rotations. But what is the general form of this now? Well, let's make a little bit of room. Let's get rid of this, and let's actually do the general form of this so that we can see it. Now, for now, the period is going to be 2 pi. So take this guy, the first one, and go pi over 3, and we're going to add multiples of this. And the multiples, of course, being n. N is an element of I, right? Or we're going to take the 5 pi over 3, and we're going to multiply or add in multiples of 2 pi, which, of course, n is still a matter of I. So here's the general form for infinite solutions. Here's the actual answer based on that restriction. Got it? Okay.